Now we look at the mass of a mole of an element or a compound. So the molar mass of an element. The mass of 1 mole of an element is equal to its atomic mass in grams. This is really, really cool. So when we're dealing with chemicals, we're not dealing on the atomic level. We can't hold in our hands 2 atoms of water. We can't do that. So we have to use something that represents a large molecule or a large number, and that's why we have the mole. So we're able, with the beauty of the mole, to convert our atomic mass units right to grams using the mole. It's awesome. So let's just look at the periodic table here. What do we mean by that? Well, if we look at hydrogen, the atomic mass unit of hydrogen is 1 atomic mass unit. But if we have 1 mole of hydrogen, that equals 1.008 grams, or we'll just say 1 gram of hydrogen. How about helium? 1 mole of helium equals 4 grams helium. So it's just moles are equal to the atomic mass of that element. How about, let's just use copper here. 1 mole of copper equals 63.546, but let's just say 64 grams of copper, 1 mole of copper. Aluminum. 1 mole of aluminum is 27 grams. 1 mole of phosphorus is 31 grams. 1 mole of chlorine is 35 grams. 1 mole of tungsten is 184 grams. Or if we want to get specific, we can say 183.84 grams. 1 mole of gold is 196.97 or 197 grams. And that means if you had a piece of gold, pure gold, that is 197 grams, that's 1 mole, and that's actually 6.02 times 10 to the 23rd atoms of gold. Of vanadium, 1 mole is 51 grams. So it's pretty cool. We can just convert these atomic mass units because we don't deal with individual atoms. We need to have it a huge amount because that's what we deal with in the lab, a huge amount of chemicals. Okay, what about if we had 2 moles? 2 moles of hydrogen would be 2 grams. 2 moles of helium would be 4 grams. I'm sorry. 2 moles of helium would be 8 grams. 2 moles of carbon would be 24 grams. 2 moles of yttrium. So 2 moles of yttrium is 178 grams. Half a mole. Half a mole of hydrogen is 0.5 grams. Half a mole of helium is 2 grams. Half a mole of carbon is 6 grams. So molar mass is just that atomic number in grams. So let's look at the mass of a mole of a compound, or the molar mass of a compound, such as the mass of a molecule, like water, or the mass of a formula unit, like sodium chloride. So this is really just looking at the mass of a compound, such as water. It's very easy. We just have to look at our periodic table here. So what is the mass of water? Well, we've basically probably done this already. We have 2 hydrogens here. What's the mass of 1 hydrogen? It's 1. So hydrogen has the mass of 1 gram per mole. And another one is 1 gram. And oxygen is going to be 16 grams. So we can see that here. Oxygen is 16, hydrogen is 1. So the molar mass is going to be 1 plus 1 plus 16. So that's 18 grams for H2O. So that's the molar mass of water. What about sodium chlorine? Sodium is 23, and we add it to chlorine, which is 36. So that's 23 plus 36, and that equals 59 grams. And we could say 59 grams per mole. And that is the molar mass of sodium chloride. Let's try something else. What about methanol? It's H3OH. Well, we know from the periodic table, carbon is 12. Hydrogen is 3, or excuse me, one hydrogen is 1. So that's 3 times 1. Plus oxygen is 16, plus another hydrogen is 1. So we have 12 plus 3 plus 16 plus 1, and we have 32 grams if I added correctly. So 32 grams is the molar mass of ethanol. So really all we have to do is add up the atomic mass units, change it to grams, and we have the molar mass. Let's try a little more challenging. Let's try sulfuric acid, H2SO4. We know that hydrogen is 1, and there's 2 of them. We add it to the sulfur. Sulfur is 32 grams. And we add it to 4 oxygens. And we should remember that oxygen is 16. And that comes out to be 98 grams. Now here we have sulfur, S. This is 1 mole of sulfur. So that means there's 6.02 times 10 to the 23rd particles or atoms of sulfur in this jar. Is 1 mole of aluminium or aluminum. There's 6.02 times 10 to the 23rd atoms of aluminum in this 1 jar. How do I know that? Well, I don't have to count 6.02 times 10 to the 23rd particles of each of these. I know it because of the mass. If we look at the periodic table, the mass of sulfur is about 32 grams. So this is 32 grams. 32 grams of sulfur equals 1. Aluminum is about 27 grams. 1 mole of aluminum is 27 grams. So that's 6.02 times 10 to the 23rd particles. This is table salt and sodium chloride, NaCl. 1 mole of sodium and chlorine is just the mass of sodium plus the mass of chlorine, and we add it up. So that's 23 grams for sodium, 35 grams for chlorine, and that comes out to be 58 grams for sodium chloride. Sucrose, 1 mole of sucrose. This is C12H22O11. Sucrose, this is table sugar. So 1 mole. Pretty cool stuff. So here we have a mole of sugar, a mole of salt, a mole of aluminum, a mole of sulfur. All right, now how about if we're given some moles of something, let's figure out the mass of something, of that certain thing. For instance, let's say we have 2.7 moles of helium. How many grams is that? So we need to look at our roadmap here. So the question was, we went to moles, we start at moles, and we want to go to mass, so we follow this arrow. That means we multiply by whatever this is. We multiply by the molar mass over 1 mole. So we start with 2.7 moles of helium. So 1 mole of helium is 4.0 grams of helium. The 11 grams of helium is in 2.7 moles. Okay, how about 2.10 moles of aluminum oxide? How many grams would that be? Well, let's first find the molar mass of aluminum oxide. That would be 102.0 grams per 1 mole of aluminum oxide. We start with 2.10 moles of Al2O3 over 1, and we multiply that by molar mass, 102.0 grams Al2O3 over 1 mole Al2O3, and we get 214 grams, the moles cancel out, of Al2O3 of aluminum oxide. Let's go from mass to moles. Okay, let's try one, start us off here. Let's try how many, say we just have a chunk of magnesium. We have 5 grams of magnesium. It's actually not too much of a chunk. How many moles is that? So we are going from mass to moles. Let's look at the chart here. We're going mass to moles. So we want to go here. We follow the arrow. We just multiply it by this. That is 1 over the molar mass. So we have 5 grams of magnesium over 1. Multiply it by the molar mass of magnesium. So 1 mole of magnesium, how much does that weigh? Or what is the mass? If we look at the periodic table, the mass of magnesium is 24. So that's 24 grams of magnesium. And we will cancel that out. We plug it in the calculator. Some of you might be able to do that in your heads. So that equals 0.2 moles of magnesium. So 5 grams is about 1/5 of a mole of magnesium. And let's just say, because we know water, we have 120 grams of water. And how many moles is that? We're given grams and we want moles. So we're given mass and we want moles. So we go over here. We're given mass and we want moles. So we just divide it by the molar mass, or multiply 1 over the molar mass. Again, we want mass. We're going to moles. So let's multiply it by this. 120 grams multiplied by the 1 mole per the molar mass. Remember, the molar mass of water is 18 grams. The grams cancel out. So we divide 120 by 18. 6.7, remember sig figs, moles of water in 120 grams. Okay, so 120 grams has 6.7 moles. Okay, let's try nitrous acid. Let's say we have 300 grams of nitrous acid. How many moles is that? So if we're going from grams, which is a mass, to moles, we need to find, we're going to multiply 300 grams 1 by the molar, 1 over the molar mass, which is 1 mole. Molar mass of nitric acid is 1 plus 14 plus 2 times 16, which is 32. So that equals 47 grams, I believe. And we divide that, 300 divided by 47, 6. Now, sig figs, so that's 6 moles of nitrous acid.